Yellowstone National Park in the United States is home to around 10,000 bison, 400 grizzly bears, and roughly 350 supervolcanoes. Well, okay, that last number isn't quite right. There's only one supervolcano there. But even one supervolcano is more than most of us would want in our own backyard. And if it were to blow, it could spell disaster for pretty much everyone in North America. Supervolcanoes are rare geological oddities. They're usually the calderas left behind by ancient lakes that have since evaporated. Their magma chambers are so enormous that when they erupt, they can eject more than 1,000 cubic kilometers of material. To put that into context, Mount St. Helens, which erupted in 1980, ejected about 24 cubic kilometers of material during its eruption. So a supervolcanic eruption is roughly 40,000 times more powerful. And if one were to happen today, it would be catastrophic. Yellowstone Supervolcano has already blown twice in the past. About 2 million years ago, it caused what scientists call the Huckleberry Ridge eruption, which ejected 2,500 cubic kilometers of ash and rock and covered much of what is now the western United States. Then, some 630,000 years ago, came the Mesa Falls eruption, which was even larger, ejecting 2,800 cubic kilometers of debris and sending ash as far away as Mexico. But both of those eruptions happened before humans ever set foot in North America. Today, roughly 9,000 people live within Yellowstone National Park itself, and another 20 million or so live nearby. If the volcano were to blow again today, they wouldn't have thousands of years to pack up and leave like our ancestors did. So we should probably keep an eye on it, right? Well, actually, that's exactly what scientists have been doing for decades. In the late 1980s, researchers began noticing that the ground near Yellowstone was swelling up at a rate of roughly 2 centimeters per year. The bulge was about 250 square kilometers wide and 30 centimeters tall, sort of like a raised truck bed. It took several years for scientists to figure out what was going on. Were they detecting the beginnings of a new super eruption? Maybe not. In 1995, they got their answer. Using GPS stations that had been set up across the region, they tracked the movement of the ground and found that the entire area known as the Yellowstone hotspot wasn't bulging upward after all. Instead, it was sliding sideways along the nearby Rocky Mountains. The hotspot itself was stationary. The magma chamber beneath it was still growing, but it wasn't growing up. It was growing down. As of 2021, the magma chamber beneath Yellowstone is about 50% larger than it was in the 1980s. But that doesn't necessarily mean anything bad is about to happen. Just because a pot of water is boiling doesn't mean it's about to spill over. The amount of magma beneath Yellowstone fluctuates constantly. Every day, about 20 million cubic meters of magma, enough to fill the Washington Monument almost 50 times over, makes its way into the chamber. Much of this magma comes from the Earth's core, where it's been recycled again and again for millions of years. It's like how every time you exhale, you're using air that was once breathed out by dinosaurs. Some of that recycled material makes its way into the mantle, the thick layer of rock between the Earth's core and crust, where it cools and hardens into something called gabbro. That gabbro is lighter than the surrounding rock, so it begins to float upward. As it rises, pressure from the surrounding rock squeezes many of the volatile components, things like water vapor, carbon dioxide, and sulfur, back into the magma as gas bubbles. When the buoyant magma reaches the base of the lithosphere, the rigid outer layer of the Earth, those gas bubbles get released and the magma turns into something called rhyolite. This rhyolite forms a magma chamber about 6 to 10 kilometers below Yellowstone, which is also where the heat from the Earth's core is hot enough to keep the rhyolite molten. Magma chambers like these are usually a lot smaller, but thanks to the hotspot below Yellowstone, this one keeps getting fed with fresh magma. Scientists think that at its current rate of magma accumulation, it will take anywhere from 600,000 to 700,000 years to fill up. And then once it does, there's no guarantee that it will erupt. So is Yellowstone an immediate threat? Almost certainly no. But in the long term, who knows? No one wants to admit this, but our planet is full of surprises. And while we may think we're pretty clever for discovering the laws of physics and inventing things like spaceships, Mother Nature is always lurking in the shadows, waiting for the chance to remind us just how small and insignificant we really are. Take, for example, the island of La Palma in the Canary Islands off the coast of Africa. For hundreds of years, residents had noticed steam coming out of the ground, and occasionally the local government would step in to try and stop it. By the early 1940s, though, the steam had become a torrent, and officials realized they needed help explaining what was happening. They reached out to volcanologist I. Sloboda Pines, who quickly determined that the island was in the midst of a volcanic eruption. The problem was that no one had realized this, because the eruption had been going on for centuries, and no one had noticed until it was too late. On September 26, 1949, the ground shook, and residents felt the first of 3 major earthquakes that would occur over the course of the next 2 weeks. Then, on October 12th, the eruption finally broke through the surface, and the residents of Toledo had to flee. By the end of the month, the eruption had formed a new crater nearly 1 kilometer wide and 220 meters deep. And during the 2 years that it continued, it spewed 2.5 billion cubic meters of lava, enough to cover the entire island in a layer 250 meters thick. All told, the eruption at Tambora was 32 times more powerful than the eruption at Mount St. Helens in 1980. In the mid-20th century, geologists used the VEI, or Volcanic Explosivity Index, to classify volcanic eruptions based on factors like height of the eruption column, volume of material erupted, and how far that material traveled. The VEI describes the eruption of Tambora as 7 out of 8, with 8 being the highest possible rating. And it's important to note that this eruption didn't happen in some remote jungle. More than 9,000 Europeans died as a result. And if it had happened a few decades earlier, when more Europeans lived on the island, the death toll might have been much higher. Even worse, the eruption kicked up so much ash that it had a significant impact on global climate for several years afterward. Estimates suggest that temperatures around the world were reduced by as much as 0.75 degrees Celsius, which led to widespread crop failures and famine. Thousands of people died as a result, mostly in China. But those are just the direct effects of the eruption. By disrupting global weather patterns, Tambora also indirectly caused famines in other parts of the world and contributed to civil unrest and war in places like India and Indonesia. Some historians even argue that it played a role in sparking World War II. What does any of this have to do with supervolcanoes? Well, to date, there have only been about 30 eruptions classified as VEI 7, but there are plenty of other potentially supervolcanic systems out there. In fact, there are 12 large calderas in the United States alone. Many of them are in remote areas, so their eruptions wouldn't affect many people. But others, like Yellowstone, sit right in the middle of human civilization. According to a 2021 study published in the journal Quaternary Science Reviews, there's about a 14% chance that Yellowstone will erupt in the next 1,000 years, and about a 20% chance that it will erupt in the next 10,000 years. If it does, it won't be the first time that we've been caught off guard. A recent study suggested that the 1815 eruption of Mount Tambora was preceded by dozens of earthquakes, which experts believe could have been detected using modern instruments. But at the time, people lacked the tools and understanding to interpret what they were seeing. Had they done so, they might have had time to prepare. Today we have similar tools. Seismometers can detect even the smallest tremors, and satellites can monitor changes in temperature and land elevation. But do we really want to use them? A supervolcanic eruption would bring down entire economies and disrupt global food supplies. So is it ethical to sound the alarm if there's only a small chance that it will happen? What if people panic and cause widespread chaos when there's no need to? In the end, it might come down to how seriously we take the signs. In the early 1980s, researchers monitoring Yellowstone noticed that the ground was moving upward at an alarming rate. But the truth turned out to be much less scary. Today, the bulge is still there and it's still growing. But the possibility that it could be the beginning of something more sinister looms over scientists and lay people alike. For now, it's yet another thing we must keep an eye on. But if the ground starts shaking, don't worry. The US government already has a plan. In 2015, the USGS published a report outlining various scenarios for a Yellowstone eruption and the best courses of action for each. One team will monitor the earthquakes in the region and issue alerts if there are signs of an imminent eruption. Another will monitor gas emissions and seismic activity in the park and maintain 24-hour shifts until an eruption is either confirmed or ruled out. A third will monitor the progress of the eruption itself and issue warnings to local communities. But ultimately, there's nothing anyone can do to prevent the damage that will inevitably result from such a massive eruption. Speaking of damage, click here to watch this video we made about why you shouldn't mess with time travel, or click here to watch this video instead.